Hello, everyone. How's everybody doing? Another day, another lecture. Today we're going to be dealing with something we started a couple weeks ago, and that's going to be nothing. Nothing, and whether nothing is infinite, and whether nothing is made of something, specifically the ether. You know, sometimes people identify space, nothing, with ether and say they're equal. They're saying that space itself is made out of particles and that there is no space, no interstitial space between the particles. How they conceive this, I don't know, but they say there are particles and everything is filled in there. And other times, or other people, they think of the ether in a little different way. They think of the ether as occupying space. Space is taken to be some kind of cylinder, some kind of balloon, cube, whatever it is. And we don't know what continues after that. But the particles of ether, right, they occupy this space. And some people also think of the ether as waves. What are the waves made out of? They're made out of particles, right? So we're back to particles. I'm not sure anybody's gotten out of that group of things. You either think of space as something separate and particles occupy space, we'll call those particles ether. We either make space equal to ether and it's all one thing and there is no space. And then there's the waves, which occupy space, fill space. Again, I don't know if it's the same thing as space or it occupies space. Keep those two things in mind. Those are very, very important. And what are the waves made of? Well, they're made of particles, right? Because what's vibrating? Well, these little particles that make up the wave, I guess, right? Well, I mean, what is a wave of? Wave of particles. So these are the issues we're going to deal with. And, one of the ways of getting to the bottom of all this is getting back to the Greeks. This is where our Western philosophy started, especially natural philosophy. In other words, not so much the theological stuff, but how is nature made? How is the universe made? Where did we come from? This sort of thing. And the Greeks started asking those questions at least, maybe even before them, but at least 600 years before Christ. And one of the early ones, the man considered the starting point, the philosopher who set the whole thing in motion, that was Thales, or Thales of Miletus. Okay, so before I continue, I always want to remind people that we have our 7th Rational Physics Conference in Borås, Sweden. That's going to be on June 8th. And maybe I can get some of you people to come down there. We've got some very interesting people coming over. And this is a good time to put your theories to the test. So if you wanted good criticism, boy, you're going to get it in there. We always have a good time. Good beer also. We always drink beer in there. Anyways, where do we start? Well, a good place to start is to look at all the Greek schools and philosophers. Not all of them, but you can say the main ones are the most important ones that deal with natural philosophy. In other words, not the soul, not that kind of stuff, not God, but how is the universe made? What is an object? They asked these questions. And there were several schools. And here I've got them outlined. Again, I want you to know that this is just a sample, maybe the most important sample, but there were other philosophers, okay? And we start out really at the Ionian school. These are the older gentlemen. We have 5th and 6th century people there, Thales and Anaximander, Anaximenes and Heraclitus. These were the first ones who started kicking around these issues, and they did come up with the four elements, and they were already talking about the ether in those days. They probably got that maybe from the East. I don't know if they were the originators, but because you find the same earth, air, fire, and water, you find the same four elements in the East. And I think the East maybe preceded these guys. So I don't know if these were the originators, but they also thought of those four elements plus the ether. And ether, I think, was also considered in the East. They called it space. They had probably a different idea of the ether. But I think this was the age when humans started thinking about these things, and I think the ether was a natural consequence. They said, well, there can't be nothing out there. What's out there? Well, that's the ether. And they probably thought of it as particles, at least the early ones. We will find out that that's exactly what their disciples or their followers or those who came later believed in. They started believing that they were really particles. Who comes next? Well, you could say that the Leucippus and Democritus at the bottom there, and they were in northern Greece. They had a school there. You could also include with them their contemporaries, people like Pythagoras and Philolaus. And then who else? Yeah, that's about it for that time period. Then you've got, the Eleatic school. They came out of the other side of Italy there. Remember, the Greeks colonized all the way to Spain. Okay, so they really ruled the Mediterranean in those days. And in the Eleatic school, you got Parmenides and Zeno, primarily the famous guy who came up with a paradox, Zeno's paradox about Achilles and the turtle. And Melissus, he joined the school in Elea, but he was originally from Samos. And I think Parmenides was also from out there. I don't think he was from Elea. And so who came next? Well, perhaps have Socrates. All these guys so far, they were pre-Socratic. They came before Socrates. Socrates kind of changed the rules. He started talking more about philosophy, politics, religion, and less about natural philosophy. In fact, Aristotle is going to accuse him of that, of saying, the quest for understanding natural philosophy, the natural world, died with Socrates. That's a statement of his. It's not totally true, but somewhat true. They started drifting into religion and politics and ethics and those sort of topics, and left, the understanding of the real world aside, more or less. It became secondary. And I include Socrates with Plato because I think, there are different opinions on this, but I think Plato reflects Socrates' ideas quite well. Who came next? Maybe the Epicureans. Down at the bottom, Epicurus. He was started a school. He said, "What you got to do is have fun in life." So a lot of people liked his school. He said, "Just do anything you like, just as long as you're happy." So they also got into a little more philosophical stuff. And then you've got the other Zeno. He founds the school of the Stoics. Okay, and really the first two, Zeno and Cleanthes, even though they're more or less important in the Stoic movement, the guy who is really gonna organize the ideas of the Stoics is gonna be Chrysippus. Okay, so he's really the guy that's gonna send everything forward to our days. And a lot of these guys, all their works are lost, or most of their works are lost. And a lot of that was picked up by Romans and people of the Roman Empire in the first, second, third, and fourth century AD. So after all this was gone, some of the books were lying around somewhere, and they got to some hands, and these people wrote about what the Greeks wrote about. They translated their texts and so on. Okay, and the last guy you can think of is Aristotle. There, he's in a class all by himself. He did start his own school, and people came out of that school, but he doesn't belong to any of the other schools that you see there. But all these guys, you got to also remember, they exchanged ideas. Okay, all these guys, they read each other's stuff, and they heard about ideas from the others, and they reached their own conclusions. They started their own schools. They said, "Well, I don't agree with that." They started their own thing. Well, what are we concerned with here? Again, we're concerned with infinity. Nothingness is infinite. Is nothingness infinite? And the ether, is nothing the same thing as ether? In other words, is nothing something? in few words, right? Um, we need to get a handle on that. One of the first guys who tackled that problem was Parmenides, and he had his Eleatic school, and with Parmenides, I think the only thing that remains from him is this poem that he wrote. In those days, people wrote a lot of this stuff as poetry. Okay, and there are only excerpts, or you can say fragments, of what Parmenides wrote on nature. And I took fragments out of his fragments. Okay, so this is not the whole thing. It's a lot longer than this. But these are the important ones, or the pertinent ones. And he says, essentially, he says, you cannot know what is not. That is impossible. He's referring to nothingness. Okay, what can be thought and spoken of is, for it is possible for it to be. And it is not possible for what is nothing to be. So he was of the idea that nothing doesn't exist. Okay? He says it's impossible. And he continues, I guess you could say that he didn't agree with the Big Bang if he'd be around today. But he does seem to kind of agree with the block universe, that it's all there simultaneously. He says the following. He says, what is uncreated and indestructible. Okay, so it wasn't created, and it's not destructible. Okay, so it's infinite, right? Alone, complete, immovable, and without end. Again, infinite. Nor was it ever, nor will it be, for now it is, all at once, a continuous one. For what kind of origin for it will you look for? In other words, no origin, no Big Bang. He wouldn't like that theory, I guess. In what way and from what source could it have drawn its increase? In other words, how did it begin to, what do you call it, inflation? The inflationary period after the Big Bang? Well, he's asking essentially questions that are being addressed by relativists these days, right? I shall not let thee say nor think that it came from what is not. Could not have come from nothing. Okay? He's got a problem with that, with the creation of something from nothing. And if it came from nothing, what need could have made it arise later rather than sooner? Yeah, why 13.7 billion years ago? Why not 6 billion years ago? Or why not, 20 billion years ago? Was there something going on 13.7 billion years ago? Was it that God had a headache or something? I mean, they just put it there. They say, well, we run the clock back, we end up with 13.7 billion. But again, we don't have a cause, and we don't have a reason also, for what caused it to happen, what triggered it. Okay? Therefore, must it either be altogether or be not at all. For what is in contact with what is. Only objects can affect objects, essentially, he's saying. Only what is can affect what is. Okay? And but the objects and the number of objects are not uncountable, are not infinite, if you want to use that word. Counting is, I like to say that counting is incessant and not use the word infinite, but here I'm using it not as a word of art. Okay. Moreover, it is immovable in the bonds of mighty change, without beginning and without end. Is not permitted to what is to be infinite. Okay, so no object can be infinite. Okay, for it is in need of nothing. Well, if it were infinite, it would stand in need of everything. That's his poetry. Survived until these days. Okay. Uh, so he had his ideas. He said, yeah, we have this infinite time in which it existed, but the number of objects and one object cannot be infinite. And the only reason he concludes that time-wise it's infinite is that he cannot conceive of something coming out of nothing. That's his main point. And he's not the only guy. Someone that came a little later than him, but sure, about the same time. And this guy was a sophist. Sophist was really a bum. That's what he was. Sophist was someone that would go out there and teach he was hired by the rich people to teach their kids. He was kind of like a babysitter. And they called him sophist. He knew all the different subjects, and he would teach them to young students, really rich students. It was homeschooling. And Gorgias says the same thing essentially as the Eleatics. He says, what is cannot have come from, into being. If it did, it came either from what is or what is not. But it did not come from what is, but it did not come from what is, since if it is existent, it did not come to be but already is. In other words, he's saying if it comes from something, that something already had to exist, okay? Nor from what is not, for the non-existent cannot generate anything. Okay, so again, all these people had the idea that you cannot create something from nothing. We had to wait, 2,500 years for the relativists to teach us otherwise. And here we have, I showed him the other day, Richard Tolson, and this fellow writes a book in 1934, Relativity, Thermodynamics, and Cosmology. And in it, he argues that you can get positive energy, mix it up, in the same blender with negative energy, and you get no energy. And of course, you can reverse the process and say from no energy, from zero energy, you can split it up in positive and negative energy. At least you can do that mathematically. And for some reason, those energies somehow, through the equation, Einstein's equation, E equals mc squared, right? E being energy equals mass times velocity of light squared. Energy becomes mass. And what is mass in mathematical physics? Mass is a physical object. They refer to it as particles. They refer to it as more often than not as virtual particles. So somehow the energy turns into a particle. And that's how nothing comes into being in this world. Okay. I got a little GIF here to show you how that's done so that you can visualize it. Okay. I'm the first one to do this. Okay. And so write it down in your books. Here it is. Here's first how particles convert to space. And if you wait a minute here, you'll see it. It's going to start in a second. Here you had two energies, plus energy and negative energy. They're going to clash. Kaboom. We have a clash and we create empty space. They fused and convert into zero energy. But what is empty space in mathematical physics, if not that which is made of particles? So again, they have this ether in relativity, in mathematical physics in general, because this idea unites both general relativity and quantum mechanics. Keep that in mind. Okay, so you have both here. Okay, you have to have not only the macro world of the universe, but you have to have also the particles that belong really to quantum mechanics, the world of the small. Okay, and you can reverse the process, and that's what we're going to do now. Again, first one on Earth. Okay, you've seen it here for the first time. Here it goes. Okay, here we take. Give it a second here. It's going to start. And there it goes. 1, 2, 3. In the beginning, there was nothing. E sub 0, right? But E sub 0 is equal to E plus minus E, right? And so what happens? Each one of these energies turns magically, into virtual particles. Now, how's that for magic? That is science, folks. That's what these people are saying. This is how the universe works. They're saying you have particles coming out of the void. And what is the void? Well, the void is a bunch of particles, but they say it's just sizzling energy. And here's the energy, coming out, separating positive from negative, and mystically morphing into particles. Now, isn't that great? That's science, folks. Okay? Current science. Okay, and one little more here. Remember that this has to be tied to the universe. Okay, that's the microcosm. You get to see the little particles there doing their thing. You get to see the little energy. You got your microscope. Now we're going to use the telescope. Okay, we're going to see the big picture. Okay. And so they talk about the finite and unbounded world of Einstein, right? Universe. Finite refers to the encapsulation, to the fact that it's got a surface. But look at what unbounded refers to. It refers to the fact that you can walk incessantly around the Earth, or around space-time, or around any object for that matter. These people are confusing apples with oranges, or like I like to say, apples with fishing, because they're confusing nouns with verbs. When they say finite, they're referring to a physical object, and they're saying, all objects are finite. We all understand that. All objects have a surface, the existing objects, right? Whereas, when they talk about unbounded, they're talking about the fact that you can travel incessantly. Okay, and you can do that around any object, the perimeter of any object. You can walk all around me for sure. If you're small enough. Okay, so the finite unbounded universe is just a language trick. Okay? It's talking in tongues. That's what it is. That's all it is. Okay, and so what does our universe look like? Well, it looks something like this. It's a universe full of particles. Okay, we got a universe full of particles. Let's wait for it to start. There it goes. This is the WMAP sequence that we get from NASA and all these great things. We don't know what that black stuff is that envelopes our universe, but we know the universe is made of particles. Okay, and yeah, we have to explain what those particles are and what are you going to call them? Is ether a good word for that? I mean, what have they changed in 2,500 years? They're saying we can map this, we see the vibration, we know the heat and the cold in this area, it's got more, in this area it's got less. So what is all that made of? Well, they say it's made out of particles. Well, isn't that the ether that you're staring at there? And what's the black stuff? I mean, that's one of the questions the Greeks were trying to answer, and here we are, we still haven't answered it in the 21st century. So, a lot of this stuff you gotta you got to wonder about all this. Here we are 2,000 years later. We have all the math, right? We have all the technology. We have seen lots of stuff out there, right? I can't say we've seen it all, but we've seen lots of stuff. We still cannot answer basic questions rationally. They have answers, but the question is, we're looking for rational answers, okay? Okay. Another fellow who had a different idea than the Eleatics was Democritus, okay? And Democritus, he said, all there is really atoms and empty space. He says atoms in the vacuum were the beginning of the universe. Nothing exists except atoms and empty space. Everything else is just your opinion. Okay. Now, what Democritus was not aware of is the so-called energy, and we replaced that energy with a rope model. You can see mathematical physics is essentially what Democritus was describing. He's saying there's just particles, atoms, those color ones on the left-hand side, and empty space. And I'm saying, well, he missed something. What he missed were the ropes that interconnect all the atoms. Okay, and that's a big difference because, as we're going to see, the rope model introduces a totally different universe. But where we do agree with Democritus is that space is just that, empty. There's nothing there. Okay, and so this ether that people were talking about, he didn't agree with all that, and I'm not even sure that he agreed with the earth, air, water, and fire. I'm not sure he agreed with that notion. Right? We'd have to bring them back alive or travel to the past to figure out, what he would say about that. And I'm sure he would have lots to say about positive energy mixing with negative energy. Okay, Aristotle comes a little later, okay, and he picks up on some of these ideas. He gets a little bit of both, and I'm not going to go through all the philosophy of Aristotle because he wrote a lot of books, and even though we found a fraction of them, there's like 70 books that we found from Aristotle. We've got a lot of information from him. And he was also, debated in the centuries that followed because there was material on him. So he became famous, I think, primarily because of that. You have to remember that Democritus wrote about as much as Aristotle, but none of his works survived. All we know about Democritus is what comes from other people who talked about him. We don't have absolutely nothing from Democritus. If we would have had something, we'd have something to compare Aristotle against. Okay, so what does Aristotle say in regards to natural philosophy or the natural world? He said he does believe in motion. He says motion occurs when objects influence one another. And he does clarify that because you have to remember that Parmenides and his Eleatic school, they did not believe that there was even motion. And maybe that needs some clarification. Parmenides, he said, there is no motion. He said, what are you talking about? Have you been drinking too much lately? Parmenides says there can't be any motion because there's no such thing as space, as empty space. He was the first to come up with that notion, not Aristotle, that there is no such thing as nothing. Because there is nothing separating, say, the particles of the ether, right? Nothing in between them. And if there were something, as soon as you remove something, something takes its place. Aristotle will use this argument later on. He writes about it, but it comes, as far as I know, from Parmenides. Maybe there's someone even before him who said all this, right? But the point is, he says there's no motion, because if there were motion, then it's irrational to say that you have a particle occupying that which doesn't exist. Because what you're actually saying is that particle becomes nothing. If by occupying not empty space, but occupying what doesn't exist, it's like it goes out of existence. So the Eleatics thought in those terms. They said, look, if there is motion, what is it moving into? It's got to move into what another object left. There's always particles everywhere. So it could be air, it could be water, it could be fire, because these are the notions they had. If you move something out, something moves in there. It could be an object, it could be a stone, but it also could be air. And so there's always a flow of matter. And so there is no such thing as empty space. And if there is no such thing as empty space, there really is no motion, because it would be irrational to say that something moves into an empty space. He considered essentially that, motion, the word motion, as he thought about it, I guess he never defined it, but as he thought about it, was moving into an empty space, like a single object in the entire universe, right? That object moves from A to B, right? It's the only object moving in space, right? But it moves in space. So there is some place in space where this thing can move into. And this guy is saying there is no such thing as space. There is no such thing as empty space. So this has nothing to move into. It's always staying there. So he was against motion. I know it's hard. A lot of people criticize him for this. You're not the only one, but I'm just telling you what he believed in. Okay. Well, Aristotle, he disagrees with him. He said, no, look, there is motion. Okay. And only objects can influence one another, can push, can pull, only objects can do it. Nothing cannot move something. There is no such thing as the push of nothing. I guess spirits don't count here as well, right? So spirits cannot push the curtain. Nothing cannot create something, okay? So something cannot come out of nothing. Again, most of the philosophers arrived at, I think there was total consensus on that issue. I haven't seen one that says something can come out of nothing. That only relativity says that, okay? And again, the nothing of relativity is energy, so it's not nothing. Something cannot move into what doesn't exist. Okay, he agrees there with the Eleatics, with Parmenides specifically. When something moves out of its place, something else takes its place. Again, that's Parmenides. He's saying there, but he says. In conclusion, you cannot have empty space between atoms as Democritus theorized. But see, he agrees with Parmenides that there is no empty space, but he does say that there is motion. Motion exists, unlike Parmenides says, because an object moves to a place, a location left by another object. That's where Aristotle differs from the Eleatics. Okay, he's saying, look, there is motion, unlike what Parmenides said. There is motion, but the way motion works is an object replaces another object. One object occupies the location the other guy left. Okay, like again, the notion they had in the back of their minds is two objects cannot occupy the same space. Okay. And he says negative infinity exists, so we're going to look at here infinity as well. You can divide anything potentially and some things actually. You can divide a rock. Okay, you chop it in half. You keep chopping. There's a point where you cannot continue to chop it physically, but you can imagine chopping it infinitely. That's essentially what he's saying. He's saying the chopping of an object infinity until infinity or forever, right, exists potentially, exists in the mind. You can imagine it, but it doesn't exist actually. Okay? So infinity exists, but only potentially. Positive infinity, on the other hand, does not exist because the number of objects would exceed the size of heaven. This is one of his arguments. The other one, because again, these people go back and forth sometime between concepts and objects, between talking about soul and mathematics and gods and talking about real objects. So they bring it all whenever they do their analysis, and sometimes you don't really know what they're referring to. But you can think of it this way. One is that the number of objects would exceed heaven, and they knew heaven, the Olympus at least, Mount Olympus, they could see it up there. They could see the edges of the mount, and that's where the gods dwelled. So they said, look, heaven is we know it's finite. So you cannot have infinite objects in a finite space like Mount Olympus or heaven or where the gods dwell. That was one. The other one is you cannot have a single object which is bigger than heaven. And then they also thought that, or Aristotle thought that the number of numbers could not exceed, the capacity of the mountain Olympus or the dwelling place of the gods, the heaven, right? It's like if the numbers somehow became mathematical objects, that phrase there, mathematical objects, and you cannot have infinite mathematical objects, okay, in heaven. The gods would go nuts. Okay, so positive infinity doesn't exist, negative does. Therefore, the universe had no beginning and will have no end. Infinity, he believed in no origin to the universe again, partly because something cannot come from nothing, and second, because you cannot have an infinite number of things, or an infinite number of infinite sequence of numbers and of time. Okay, so he just didn't believe that there was a beginning, primarily again because you can't create something out of nothing. And he did believe in the ether, but unlike Plato, he says it exists out there beyond the moon. Plato thought that ether was here with the other four elements, so there were these five elements, the fifth element, the quintessential, right? And he believed that it was here on Earth, whereas Aristotle says, no, look, it's out there beyond the stars. It's what the gods breathe, okay? And so Aristotle disagreed on that issue with his teacher, Plato. Okay? So that's for these guys. Stoics, they came up with something different. And the Stoics came a little later, okay? And the main exponent, I guess, is Chrysippus there of Soli. Soli is a place in Turkey. And the Stoics really were, most of them were from that region, and he essentially agreed with everything Aristotle and Parmenides said, but he disagreed on one issue, and that's that beyond the ether, there's, I guess, some particles or nothingness. And by the way, that picture you see there, that's not Photoshop. That's an actual photograph of the days of the Greeks. And what they photographed is a relativist looking at a four-dimensional cube, because that's essentially what relativists say today, that, beyond the ether, I mean, what's on the other side of the edge of space? If the ether stops somewhere, right, the number of particles, these events, as they call them, points in space-time, what continues after the points in space-time? What's out there? What's that white stuff? And Chrysippus was trying to, answer that question. And he says, look, he could not imagine what's out there, but he just gave it a shot. And he says, he believed there was something beyond the ether, whereas Aristotle did not. Aristotle converted that white stuff, that white region, into an ether as well. He said all that continues after that is ether. And I guess he thought about it as infinite ether. But then, again, how does he deal with that in Mount Olympus? Well, I guess the edges of heaven, of the heavens, or ether just filled up to the edges of the heaven. I think that's the way you got to look at this. Otherwise, I don't know what Aristotle would suggest comes after the ether. And that's what Chrysippus was trying to answer together with, the Stoics were trying to answer. And they said, what is that white stuff? And they said, well, there's some undefined divine stuff that's out there. And that was the notion that essentially came out of the Greeks. Then the Greek civilization died out. They were conquered by the Romans. Romans picked up a lot of their theories, a lot of their ideas, a lot of their statues and so on. They imitated a lot of the statues. Otherwise, we wouldn't have some of the images of the philosophers today. Not that any of those are the right ones. Only a couple of them are. Most of them are not, because they don't know who some of these statues belong to. But the Romans, since they made copies, they made copies of the Greek statues. They said this guy's this so and so, and Chrysippus was one of them. He got portrait. His statue was copied. Okay. Just one more thing here. There's Aristotle's view of the ether. Okay. And again, what he thought really occupied beyond the ether, I don't know. The ether just, for him, continued eternally. and I would think it just filled um, the heavens. In other words, where the gods dwell. That's probably where he ended up with his notion of ether. Okay, what happened next? Well, what happened next? Well, one more guy here. Philaeus, just along the same lines, and that's probably where some of these Greeks got it from. It's that, they had the stars in the ether. That brown stuff, that's the ether. Okay, the heaven of the fixed stars, right? And what was beyond that is the other outer fire. Okay? So you had the inner fire, the earth twirled around this fire, and they had a twin. There was a twin Earth on the other side that we would never be able to see. One was always going around the fire, and the other one was not exactly 180 degrees from it. But then the outer fire was encompassing the ether where the stars dwell. And so Philaeus can be probably credited with this notion. Okay. And it was picked up by other generations. I think few people picked up on Aristotle's notion. At least it didn't survive uh, during the Middle Ages or the Dark Ages, we can say, the beginning of the Christian era and so on. And part of it is that, some of the philosophers, as I said last time, began to take some of these things, the ether, and they started incorporating it in our lives. They say it's not out there. It's not only for the gods, like Aristotle said. They brought it in there. You probably heard about the flu. You get a cold, the flu, and that comes from influenza. Influenza means influence. And influence was from the stars. When you got a cold, it was because the stars, sent their ether at you. This soul, this spirit that penetrated your body and made you sick. Evil spirits, obviously, right? And so the ether would come. So people developed these ideas a little more, and they said, yeah, and they started getting more into religion, into soul, into conscience, that kind of thing, mind, and sickness, because that was, with them every day. They saw people die more often than we do these days. People would die at the age of 20. Babies would die faster than they die today. And so they said, evil spirits. And what were those evil spirits? The good ones and the bad ones, both. You had the dark ones, like Plato said. The last time I showed you that, I think I've got him there. Hold on, let's see if I have him in there. I think I do. Where is he? Here it is. Yeah, see, you can see Plato says at the bottom, there are similar differences in the air, of which the brightest part is called the ether, and the most turbid sort, mist and darkness. Well, that's the evil versus the good ether. Okay, that's Plato's version. I think it's Plato's version that won the day. And so when they looked at these things in the first centuries of the Christian era, they started incorporating a lot of Platonism into religion. A lot of these people read Plato and they read Aristotle, and I think they stayed with Plato because Aristotle was too mechanistic, too, you could say, not as atomistic and materialistic as Democritus, but he was still, a guy who tried to rationalize this whole thing. They said, you can't, forget it. We're going with Plato. We're going to do it irrationally. And that's what survived, really. Okay. What happened with all these guys that came after? Well, again, we have Zeno, and we have Chrysippus, and we get all the way to, that's still in the old era of the Greeks. Then we have in the Christian era, we have Plotinus. And he starts, he's one of the guys who mentions that the ether is the vehicle of the soul. So he does bring, the ether into our lives. He said, look, it's all around us. It's this soul, it's this spirit, this ghost that lives with us. And even though you had people like Marcianus there that did astrology, and he looked at the stars, and he still had this vision, similar to Aristotle's. It's people like Plotinus that win the day. They essentially incorporated the ether not only within astrology, but they incorporated within this religion, the soul. And probably the most important guy who did this or who dedicated his life to this type of thing. He wasn't the only guy. We had Anselm, we had Aquinas. So I'm not going to deal with religion here. We had Mr. St. Augustine. The reason I bring him up is that, he was there when the Roman Empire fell in the year 410. And he wrote it in his Confessions that something that went against Aristotle. And that is that, yes, there was a moment of creation. And the Bible tells us what that moment of creation is. And that's that Almighty God created, the universe. He just went out there and what did he create it from? Well, he created it from nothing. He says there very clearly, he says, just the title, out of nothing God made heaven and earth. Okay, and you'll find this in book 12, section 7. I'm not going to read all of it, but I just want you to know that, yes, these people considered that, and they started going against the teachings of Aristotle. What really won the day was God. And the source for this notion that there was a beginning to the universe, to time, to everything, to space, to matter, God. Where did all that come from? He made it from nothing. I thought we couldn't turn nothing into something. Well, the Greeks thought that, but once we brought God in, he's all powerful, he can do anything he wants. Now it's a piece of cake. He just takes nothing and converts it into something. That's what St. Augustine believed in. He believed that you just convert, God is all powerful. He can do anything he wants. In fact, there was one, can't remember the author, but it made me laugh because he says, God is so powerful, he can return the virginity to a woman. A lot of women would love that. Maybe they're praying to God to see if that happens. Okay. So what happened with the ether and with nothingness and with the cosmos, right? What do we make of that? Well, throughout the next centuries, without going into detail, because really nothing much happened, what we have is a lot of alchemists and astrologers. And they go through there and they use all these notions, these concepts that they got from the Greeks, whatever the Romans also bequeathed to them, and other ideas like from people like St. Augustine, Anselm, Aquinas, and so on. And these were astrologers, essentially. Astrologers, a mixture of astrology and alchemy. They did a little bit of everything. And they also did God. As you can see, some of them were people from the church. First four up there for sure. Copernicus, he was a priest. None of the others, Paracelsus and Tycho Brahe and Kepler were not, but they were, these people did alchemy and these people did astrology. And they brought these notions over, okay? They did use the notions of the ether, of nothingness, the infinity, and essentially they just went along with the theories of the Greeks. They read Plato, they read Democritus, they read the Eleatics, and they read Aristotle. And they reached their own conclusions, a mixture of all of these. Some believed in this, some believed in that, just like the Greeks. Nothing essentially changed. One of the persons who's going to make a little bit of change is Mr. René Descartes. Okay? And I'm not going to go through all his ideas, but just the ones that relate to, again, nothingness, infinity, matter, the ether. Descartes believed that the universe is made of particles, just like Democritus, right? But not of empty space. He did not believe in empty space. Ring a bell? Yeah, someone already said that, in the past. He says, empty space cannot exist, for otherwise, as Aristotle theorized, matter would instantly occupy the empty space left behind. Okay, so he just likes those ideas. He's just taking it from the Greeks. He gets rid of one of the elements. In fact, he gets rid of two of them, I guess. Not really the ether, but he does get rid of water. He says everything is made of just three elements. That's where all the Greeks failed. They would have listened to me. He says it's just earth, air, and fire. That's it. That's all everything is made of. And objects do move, even though there is no empty space. So here he's agreeing pretty much again with Aristotle. There's no empty space, but objects do move, and they just occupy the location left by another one. So they don't give time for there to be empty space when something already occupies it. Again, it could be air, it could be anything. And he comes up with laws of motion. Some of them later are given for unknown reasons, as far as I'm concerned, to Isaac Newton. He says an object stays in its place until something collides with it. Well, yeah, that's more or less the third law, Newton's third law. An object loses motion a bit, loses a bit of motion when pushing another, and all parts of a body move in a straight line. He had this idea that Newton's going to incorporate into his first law of motion, saying, objects move in a straight line unless something else pushes it around. That's pretty much what B and C are saying there. Newton just took those two ideas from Descartes, and he did read Descartes completely. The circular motion of particles of the ether are the ones that compel planets to move around the sun. The reason they move in circles, well, it's because the ether particles are moving in circles, and that did come also from Aristotle. Aristotle was the one who came up with that idea first. Cause of gravity, well, ether is lighter than air, right? So air cannot go up into the heavens. Rocks, they cannot go into air because the air is lighter than the rocks. So it was all a weight kind of thing. Something is too heavy to go, beyond the air, so it cannot fly, cannot float until, the Montpellier brothers invented the balloon. I guess they never saw something heavier than air flying, except maybe some birds. But I guess for some reason they say, well, that's a living thing. He flaps his wings. I can understand that. So you had to be lighter than air in order to beat gravity. And air could not beat gravity because the ether particles were lighter than air. Okay, the cause of gravity. Then we go to the ether particles. Descartes believed that space is filled with particles. So he didn't come up with it, but he already believed in the idea that ether is what's out there, and the ether is made of particles. And there you have the little picture on your left, just a bunch of particles out there in space. And light has the ability to travel through this ether, right? And light travels instantaneously. Okay, remember, it's not until first guy to prove that or to realize that light has a finite speed, he's going to come in like 20 years after the death of Descartes. Okay, and it's going to be Huygens who's going to put that in black and white. He's going to write about that, saying that the speed of light is finite. It's going to be Romer, and he's going to show that the moons of Jupiter, when they go around, behind Jupiter, they should come out because they knew what the speed of the moon was. They were able to measure that. Romer was able to measure that. So he knew what the speed of the moon was, and he expected it to come at a certain time. It did not. And he said, oh, Jesus, why didn't he come out? Something's going on. And there was a delay. And he measured it again 6 months later, and he found out that, no doubt about it, the moon was falling behind when it went behind Jupiter. And he says, I know, the speed of light. See, we're over here when 6 months later, we're on the other side, right? We're farther away from Jupiter, and now the speed of light takes time to get there. And he calculated the speed of light to be about 10% off from what it is today. But if for the first time someone showed that the speed of light was finite, that was Romer. Huygens is going to write about that, but Descartes, he had died already, so he did not know that the speed of light had a speed. In fact, both him and what's his name, Galileo, they believed that the speed of light was instantaneous. In fact, Galileo runs a funny experiment where he's got his assistant on one mountain, he's on another mountain, and they both go with lanterns. He says, "Look, as soon as I take the veil from my lamp, you take from yours, and I'll see how fast it takes light to reach me." And he timed it as several times. He finally concluded, no, it's instantaneous. And Descartes, I think, took from him and believed in the same thing. It's not going to be until 20, 30 years after the death of Descartes, René Descartes, that Romer's going to show that, no, light has a speed. And from there on, they started measuring the speed of light, Bradley and later on Michelson and so on. Okay, I'm going to continue with the 17th century scientific revolution next time, this Wednesday, okay? 1900 hours, what is it, Eastern Standard Time? I think I got that right. No, UTC. It's 1300 hours, I think, Eastern Standard, or 1500 hours Eastern Standard Time. So yeah, I'll see you on Wednesday. I'm going to continue with the scientific revolution and how the ether takes on a more, becomes less religious and becomes more, we'll call it scientific. The scientists, the mathematicians are starting to look deeply at the ether. And two primary guys are Huygens and Isaac Newton. We'll see you on Wednesday. See you then.